Hello friends. So today we will be learning about TVS diodes, what its functionalities, where it is used, and what are the different applications. So I will start with what is a TVS diode. Now, TVS diodes are basically transient voltage suppressor diodes that are used for protecting your sensitive electronic equipment from high voltage surges, or you can say your transient events. So there are different sources of high voltage surges like surge, electrostatic discharge, surges as per IEC 61045. Then you have your inductive load switching that might impact your electronics, and these are particularly the sources which generates the high voltage transients that might that might damage your electronics, your load. So I have given one small picture just to illustrate how it is connected. So this is TVS diode is basically connected in parallel with your load that you are protecting. So this is your electronic load you are protecting from the high voltage surges that is being applied at this connector. So here I have connected the TVS diode in parallel. So now we will understand what is the operating principle of TVS diode. So in normal operation, it does not conduct. So for any kind of normal voltage that you apply, so this will be absolutely, there will be no current and it won't be conducting. Whenever your transient event occur at the input, then basically what it does, it sends the excess current to the ground, thereby protecting your electronic loads, whatever you have connected. Okay, now we will go to the TVS diode, different types, and where it is connected. So there are two types of TVS diode. One is unidirectional TVS diode, and then you have your bidirectional TVS diode. So there are two different application. One for unidirectional TVS diode. So whenever your signal level always stays at positive, it does not fluctuate to negative. In that case, you can use unidirectional, so that the excess surge current that will be shunted like this. But when you have your signal that fluctuates between positive and negative, so in terms of when there is a negative voltage appear here, then the current will flow from ground to the lower potential, the negative. So that means you need to have a bidirectional TVS diode to protect your equipment. So these are the application of unidirectional and bidirectional TVS diode. Now where it is connected. So for electronic designs, TVS diodes, as I mentioned, it is used for protecting against your electrostatic discharge. So electrostatic discharge as per IEC 61042, usually air discharge or contact discharge, that voltage is in kilovolts. So that voltage usually appears at air. That means your enclosure will be injected through the ESD through air, or your openings of your enclosure. That means wherever you have your connectors on your system, there you will have your contact discharge. So you need to connect the TVS diode at those connector output where the signal of your board will come out or will come in. So there, and then you have your power supply input. So at your power supply input connector, there is a possibility that surge voltage may appear. So you need to connect at the input of the power supply to protect your regulators against the high voltage surges. So now there are some key parameters of TVS diode we need to understand before we actually select a TVS diode for a particular design. This is the VI characteristics of a particular TVS diode. If you see, it is exactly similar to Zener diode, but it has an additional provision of suppressing the transients, which Zener diode does not provide. So it basically provides, this TVS diode basically provides overvoltage protection as well as your surge protection. So this is the TVS diode. To understand its operation, you need to select, if you are selecting a TVS diode, then you need to know what is the maximum operating voltage of your board. Once you know that, then select a TVS diode that will have VRWN same as the maximum operating voltage of your board. So VBR is your breakdown voltage, that is the voltage at which your junction breaks and your current just starts to conduct. I mean, your TVS diode starts to conduct. If you see, the current would be around, the test current would be 1 milliamps to 10 milliamps. So VR will be slightly above VRWM, where your actually excess surges current starts to conduct or starts to shunt through that. Now VCL, this is the clamping voltage. So clamping voltage is the maximum voltage where your TVS diode will start to regulate. That means above that voltage, whenever there is a transient event or any high voltage surge, so that will be shunted directly to the ground and the TVS diode will conduct with its full potential. You need to select a TVS diode which has a clamping voltage equal to or lesser than the maximum absolute max rating of your board. So that above that particular voltage, whenever there is a transient, then that will be shunted through your TVS diode. IPP. This is one of the critical parameter. IPP means peak pulse current. So this is the maximum current that your TVS diode can sustain without damaging the junction. That means above your clamping voltage, when the transient, when your TVS diode suppression starts, then in that case, the current should be limited within the IPP value so that this TVS diode will not be damaged. Now, if you are selecting a particular TVS diode for your application, just to give you an example, suppose if you have a board that operates at 3.3 volt. So this is the normal operating voltage of your board. Now, if you see all these ICs that you are driving, then there is an absolute maximum voltage rating. So for 3.3 volt, it is around 3.6 volt. So this is the maximum voltage your ICs can sustain without damaging. So you need to select a TVS diode that has a reverse working maximum as 3.6 volt. That means until 3.6 volt, your TVS diode will not conduct. So once the TVS diode, once the exits the 3.6 volt, then it starts to conduct at breakdown voltage. So as I mentioned previously, VBR is always slightly higher than VRWM. That means if RWM is 3.6 volt, then VBR is around 3.8 or 3.9 volt. So this is the voltage at which your TVS diode starts to conduct, where your PN junction will break. So now you need to know the clamping voltage for selecting a particular TVS diode for your application. So clamping voltage selection will need. So clamping voltage is basically calculated as V plus IPP to your RD. Dynamic resistance can be calculated by VBR plus IPP. So when I say IPP, so this you need to calculate the maximum surge current that can be allowed through your TVS. You can find it in the datasheet. So based on that, you can calculate. So you need to select a TVS diode that has a clamping voltage which is lesser than the absolute max of your board that can be handled by your board, absolute max. IPP is, as I mentioned clearly, it's peak pulse current. It is the maximum voltage. It's a maximum current that can be handled by your TVS diode without damaging the junction. So IPP is basically calculated. For selecting a TVS for your application, you need to calculate what is the maximum surge current flowing through your system. So that can be calculated by knowing what is the surge type appearing at your input. So suppose as per IC 61004-5, if you consider 1 kV, so it's 1 kV divided by your Z. So if you know the impedance of your board, then you can easily calculate your IPP. So in this case, your IPP, suppose I'm just saying, you're calculating as 30 amps. So you need to select a TVS diode that has an IPP higher than 30 amps. So that will be appropriate for your design. Now, one more critical parameter that you need to consider for TVS selection is your power of your TVS diode. That can be calculated VCL multiplied by IPP. So this will be as per your data sheet, whatever clamping voltage you have selected for your design, and you know the maximum IPP. Then your data sheet shows the so this is the maximum surge current, I would say. Now, if your VCL is, as I mentioned, it's around 6 volt, then multiplied by your maximum surge current, that is around 30 amps, as I said. So it will be 180 watt. So you need to select a TVS diode that has a power rating higher than 180 watt. But if in case you are not able to restrict it below 180 watt, you have another option to add a series resistor through the TVS diode such that the surge current flowing through that particular path can be reduced. So in that case, once the current is reduced, then obviously your wattage, maximum wattage also can be reduced. So then you can also select the TVS which has a lesser wattage, but it is always wise to select a TVS diode with a power rating higher than your maximum power dissipated on your board during transient event.